So today I'm going to look at something a little bit different. I've been asked to look at this by someone. They've had this thing for a while. Apparently it failed a while ago and they haven't really bothered with it, and they gave it to me a couple of days ago to have a look at. And it's a solar charge controller. So it's a EP solar tracer. I think it's like a, I don't know what the current rating is on this one. It's a 2215RN 20 amp rated. Details on it there. So dual voltage things, you can change them between, you know, if you're doing 12 volts, 24 volts, whatever. It's got some liquid damage on it. Yeah, liquid damage. So let's open this thing up. As you can see, it's already been basically dismantled. It's kind of wedged there. Alright, so it's got the top cover here. Nothing too special about that. And you can see it's already taken it all apart. He apparently had a bit of fun getting it apart because of all the silicone in there holding it all together, which is actually a good thing because it stops vibration from causing these things to basically break all the solder joints. So the fact it's got silicone in it is good. Capacitors look okay, at least on first glance. Those look fine. And there's the housing. You can see some witness marks on the housing here. That doesn't look good, does it? Yeah. Stick it on the back. Now in this box here we've been given a cable, or a couple of cables, and a display module. Now I used to have one of these things in my motorhome years ago. I've now got a Victron system instead. I used to have something very similar to this. I think I had the 50 instead of the 5, but it's basically the same thing. Works the same way. So we've got that to do testing with, if we get that far. So it looks like the fact that there was liquid damage in this area here on that top corner, that the unit, instead of being mounted up this way, alright, it's supposed to go that way up. I don't know, maybe it ran into it, I don't know, but you can see it's also staining just there too, bit of rust stain just there. So I don't know, maybe it was that way up and it dripped down and sat there, but it looks almost like it was that way up because it's coming off this wire here, which means it would have been this way up. That's where the Ethernet cable comes. It's actually not actually Ethernet, but it's a RJ45 plug, I should say. Alright, so it comes in here. This area here, apparently it's already been cleaned up a lot. The guys already done a lot of work on it to try and clean it up, but it's still not working. So this area is the one of concern. You can see the solder mask here is like changing colours. Means there's corrosion underneath it. And all these traces here, these wires need sorting out. All that needs doing. That trace there might be completely cut open. I don't know about under here. I think there's probably alright. Looks like it's probably alright under there. Maybe. I mean, see some discoloration still. I don't know if it tracked across here or not. Nothing really over there anyway. Can we see better under here? Can we use the camera? Let's get a torch as well. Oh, need more light. More light. Those. Yeah, those wires there have been affected. There's one just there underneath that transistor which has been affected. Maybe that one there too, see a little hole in it. So I might need to get under there as well. Yeah, I think I might just need to touch up that one there with the soldering iron. I can probably get to it from this side. You know, just solder it from this side, it'll probably be fine, it'll probably pop through. So obviously that area there is all affected. And on this side of the board, if you flip it over, well, this area here is affected slightly. But say it has cleaned up a lot already, but you can see that there's some crustiness on these, like round that area there. It's not looking great. It's not too bad. Could have been a lot worse. I've seen far worse than this. In fact, I've done videos about far worse than this. So part of this is just having a look around, see what's going on. Maybe just reflowing everything. It might be simple as just chucking some flux on it, heating it all up and reflowing it. That might even solve half the issues it's got. That wire there is looking a little bit iffy. But I mean the traces on this side aren't looking too bad. It's like the other side's the side that got most of the hit. So it's not too bad. And down here. Yeah, okay. Microcontroller there, which is obviously running a display and stuff like that. I'm a little bit too zoomed in, aren't I? Let's go out slightly. So then we've got this device here which is doing all this controller. So that's like a controller, that's a microcontroller. You know what I mean? So this is doing the display, all the interfacing. Got some power supply stuff around here, obviously. And over here, we've got some problems here. Look at this. Some water got just there, and just on that controller pin there. So I mean, it's not that bad. I've fixed far worse. A lot of this will just be a case of refluxing it and resoldering. As far as tracers go, it's like there's nothing really to rebuild. There's only like one tracer scene which needs rebuilding, at least so far. So I think it's actually not too bad. Now really we should probably take this connector off and have a look underneath that and see what's going on under there, because the fact that that's where the water appears to have gone in, there could be problems on the top side of the board, so that probably needs to come off. And it's actually, look, the actual earthing for the casing, I suppose I have a resistor there, but it looks like it's, is it missing or it's not populated? Can't tell. Looks like it was never populated. So that's interesting. So it's got a floating chassis earth here. Bit unusual. Anyway, so yeah, a bit of work to do on this. But like I said, it's not that bad. A bit more of a look on this side. There's some scratches here where the guy was trying to get the thing out of the casing. Hopefully those aren't cut through, but if they are, it's not a big deal. Those will be easy to fix. So first we'll test this out and see what's going on with it. I've got this hooked up to my power supply, obviously, with its cables. I'm going to hook up the battery one first, so that's the middle connections here, which is my channel 2. So channel 2, we'll turn that one on first. That's set to 13.8 volts, 800 milliamps. Okay, that booted. It's only drawing 20 milliamps right now though. It looks like there's basically nothing going on. I just see a flash over here. Yeah, so it goes here. That light there's on. Battery green. I'm presuming it's set up for 12 volts, not 24 volts. I'm going to start with 12 volts first. And then we'll do channel 1, turn that one on, which should be the solar array, effectively. PV's not showing up either. No current being drawn. So it's either completely dead, or it should be running on 24 volts. So let's crank up the solar array, because that would be a safe one to adjust. That's 15 volts going in now. Still no change. I don't really want to change anything else. The solar's on but dim. The battery is LED is not looking very good. Yeah, it's barely showing up. Probably to do with this corrosion in the area. I'm just suspicious that there's nothing much going on. Push that button there. We've got 17 showing up there, which is mode and timer. Timer 2 in. Battery type 2. I don't know what that is. But anyway, so that's working. The controller is working. Okay. So we got that part. If I put the solar back up again, I'm not seeing any current change. Oh yeah, I'm seeing a different current on the battery side. Could be the solar voltage too low. Let's change to channel 3. I'll come back. I might show you this in a second anyway. I'm now on channel 3 instead for the solar, because that can go by 15 volts on power supply. And if I was shoving it at 16 volts, to start to see current going out of the solar, went to the solar's connections, and the current on the battery changes as well. Go 17 volts. It's not doing it now. 18 volts. You get 23 volts. It came on. 22 volts. I've got 500 milliamps. 50 milliamps coming out. Yeah. So the solar array input is now working. That's trying to drive the actual unit. It's actually powering the unit. And here you can see it's flashing. Maybe you can see it's flashing. That means it's trying to charge the battery. So the actual controller side is working. It is indeed, the solar's working. The battery state is working. Does that change anything over here? I doubt it. 17 in. Nah, okay. So that stuff is working there. So the solar, 20 volts coming in, which would be effectively simulating a solar array. Yeah, okay, that's good. So that part works. And there's power supply. That's doing the solar, and that's the battery. Alright. I don't have an SMU, but you know, it kind of works. Well, I actually do have an SMU, but it's massive and it's bigger than my desk, so I don't tend to use it. It's an old one. Still doing 60 milliamps. 19 volts, it's dropping down. because the MPPT, don't forget, so that tries to adjust itself. 16, you see the current here now, popping up every once in a while. 15, there we go, now we're running on battery side again, and wind it back up, it's gone off. Bring it back up to a decent voltage, so it'll start kicking in. Maybe. Maybe not, it's only a think. Come on, kick in. No, it's not doing it, it's having a rest. Things with MPPTs, they can be a bit finicky. Right, turn it back on. There we go. 24 volts and it's starting to ramp up. Yep, so that the MPPT sides are working, the solar charge control works. So I plug the cable into the display, let's plug this into the unit, see if there's anything. Absolutely nothing. Completely dead. Okay, let's power it off. Power on the battery again. Power on the solar. Still nothing. Okay. But I think that's probably corrosion related. Okay, now we know what the symptoms are. We know that the controller itself is working, which means it's worth pursuing it further. And what we've got to look at is all the corrosion in this area to get the communication working. So the first thing I'm going to do is put some solder on these connections. I'm going to take this connector off first and have a look under that, in case it's like completely butchered and there's nothing I can do about it. That's the first step. So we'll just put some fresh solder on these joints here, try and get rid of that ugly solder. It's not likely to go well. Once these things corrode, the solder just ages badly and doesn't really go very well. When it oxidizes a little bit, it's just not the same. So sometimes you can get it back by putting some fresh solder on. It will come back and then it will flow. But often it doesn't even take solder. So we'll just try this. Just blob it up on there and see if we can get it to actually flow at all. So there is something happening there. Alright. Because I'm also trying to basically refresh that solder with new stuff. Okay, let's do these pads here as well. Alright. Okay, that's flowing. It's not too bad. Okay, that's not too bad. Let's get the desoldering gun on this and we'll clean this up. I think my pin is completely gone. Some of these don't feel good. Yeah, some of these I'm not happy with. Yeah, a couple of those I'm really not happy with. Okay, and that one there. Yeah, I'm going to have to use hot air to get this off. That is not going to drop off by itself. Hopefully, I can just lay it down like that and it'll be okay because it's actually on the disc. So, let's do that. Let's use hot air. Right, I'm going to use a lot of heat. That heat actually came off with that one. That's off. That's off. That's just these ones I think I need to do. Okay, off. Putting holes up where it's still hot. hopefully. Come on. Doesn't want to flow through. Set one done. This one's being troublesome. Well, next to it's looking like it's only barely clear. I might do that again as well. Yeah, I know it seems counterintuitive to put more solder on, but it actually helps. See? Clear. Right, so the pin's done. Well, the hole's done. Let's clean this up. And the reason I want to take this off to see if there's anything underneath it, which is an issue. There isn't. There's nothing there. So that was taken off for no reason whatsoever in the end. But at least we know that there's nothing there. So it's all on this side. That sort of tracer's there. See, there's the solder mask that's peeling off. The heating helped that. You can see where it's got the water all underneath it. Those marks you can see before where it's all sort of ripply. So all this has to come off. Otherwise it'll just eat away underneath the solder mask. It's got to come right down to here. All that's got to come off. But that's alright. I knew that was going to happen. Right, so you can see I'm getting a bit of a scrape up there and just got rid of the worst of that. Next step is fiberglass pen. Just to see how we go with that. This might reveal more issues or show things that are going on, which may not be so obvious before. Right, so that trace there, like I said, I thought that was eaten through. It looks like it is. Looks like that one's completely gone. See that? And we can see there's actually got very few connections going here. So we've got a 0 volt there, earth trace, and to here. So it's a shield, a shield, a shield. So we've got 3 shield pins. That pin's not used. Those two there are linked together, which means that's probably the main power supply coming in. And then we've got 2 more lines here, which are probably the data lines. So as for things completely dead with nothing at all on display, I think that being dead there, not communicating, is probably what the main issue is that there's no power coming down from down there. So I think this is what we need to do, is just clean all this up. And it's not too bad. I've done far worse. If you want to see worse, I've got a Farmtech Polaris timer, which was covered in what appeared to be dog pee, and I had to rebuild all the traces in it. Well, many of the traces in it. So that was a pretty atrocious one. I actually haven't finished doing the videos on it yet, but maybe by the time this one comes out, that would have been done. They've all recorded and everything, I just haven't finished editing and publishing them all. Yeah, that's that side anyway. So I think this bit here is the main problem. So we'll clean this up. And obviously there's that wire under there which I need to get to yet. And sort that out. But yeah, it's not too bad. It's not as bad as it looks, I don't think. Right, so next thing I'll do is flux and boil where all the corrosion has got to on this side of the board to try and stop it getting any worse. Apparently it's been a few years since it's been used, so you know it hasn't really progressed much. So it might be fine, but once it gets back into use and there's electricity running through it, you can actually accelerate corrosion by that if there's any moisture left or slight bits there. So I'm just going to basically put this area here in flux, heat it all up. There's also a bit up here which has got corrosion on. I might give that a brush before I stick that on. Let's brush it off. Try and clean up a little bit there too. There's a bit on the top of that chip just there. Again, this is all really minor. Most of it's just surface corrosion, it's not really a big deal. So, I'll just do this as well, generally, in case there's anything left over here. Alright, but it's not that bad. So, stick some flux on this. I'm just going to do a flux and boil, because sometimes that's actually all you really need to do. Put a bunch of flux on it, and just try and clean it up with that. I think it has all gone around the power supply section over here. It does look a bit dull in this area, so I'm just going to do that, and over here, and on that chip there. Right. I'm just going to do localized. Doing this technique is messy, it does make a huge mess. I'm going to use a lower temperature. I'm not trying to desolder it, I'm just trying to melt the flux on. Well, trying to basically flow the flux and neutralise corrosion. That's what I'm going for here. I'm using 350, so if I leave it on too long in an area, it would actually melt the solder. So it has got the capability of doing that, but I'm just trying to get the flux to flow. I mean, I could probably reflow these things quite safely. I'll not turn my extractor on. I didn't actually plan to have it. In this area, because it is right where it was, I'm going to try and reflow these a little bit if I can. Like I said, most of it is on the back of the board anyway. But like I said, the guy that did this, the guy that owned this thing's already cleaned up a lot of the corrosion, so I can't see exactly where it all was. I can see kind of where it was. So I am actually reflowing all these parts. Seeing the solder go shiny, and I'm moving on. Got to be careful around the capacitors, don't make those explode. Okay. Just worry about this resistor pack that's down here. Alright. Let's let that cool down. This reflection's not helping, is it? Just the wrong angle. Anyway, I'm putting some IPA on it now, just to try and help wash off some of the flux. IPA is cheap. It's not the most effective flux remover, but I use it because it's cheap. It doesn't cost very much, but versus a spray can of flux remover, which is like $20 or $30 or something stupid like that. Whereas I can buy like a massive bottle of IPA for like, I don't know, $15, something like that. And that will last far longer. Anyway. If it's really stubborn, I will use flux remover. I do actually have cans of it. I do have some. It's not like I don't have it. I just don't tend to use it because it is expensive, and I find IPA is fine if you use a bit of patience. We'll do alright. Okay. You might have to do it a few times, that's all. Anyway, that's that. Let's clean up this side and fix these problems over here. So there's a little via just down there which I spotted before, so let's just try and solve that, because it looks a little bit suspicious. And there's another one over here. These ones I can see like this. Alright, let's just fix these up. There's still some bits of flaky stuff lying around. This end's not looking too bad. There's a few little bits which I'm just thinking, yeah, it could be better. Just give them a hit with a soldering iron. Iron's probably a bit cold actually. What's it? 330? Let's go up slightly. Let's go 350. The trace here is completely gone as expected. Some vias here which are hopefully viable, like the pun I did there. Might have to look at these. These are not looking good. It's kind of coming back. Okay, that one's come back just. Yeah, okay, I have to check. I think I have to check the continuity on these ones, but I think they're okay. I think these ones got lucky. Yeah. Yeah, I think we're lucky with those. Okay, there's another one just there. Now, what probably is a good idea to actually flood this whole plane with solder to protect it, or just put some more solder mask on. Now, I'm probably going to do solder mask because I think it's probably going to be better. This is a capacitor leg here. So there's vias everywhere which need to be definitely okay. Yeah, I mean they're taking solder okay. I'm actually quite surprised by that. You know, they could be better, but I've certainly had far more resistant than that before. So rows vias here. Let's make sure those will work. One risk with this is because the solder mask is gone, is actually quite possible to accidentally create a bridge and short it out if a via is on an isolated land, you know. So that's something I'm trying to be careful of as well. Some more solder mask coming off. Now, because I've done the hot air on the other side, that is probably helping this side come a little bit easier, because it's already kind of reactivated the solder with the flux and everything, which may have flowed through. If in doubt, give it a slight scrape. Okay, I think we're doing alright. I think we're doing okay. Okay, I'm fairly happy with that. Let's have a close look up here where we had that corrosion before. See if that flux has done the job, or if I need to do more. Yes, probably not too bad. Looks like it's gone. So I'll give this more of a clean, but that should be alright, I think. Excellent. So let's rebuild this trace which has been destroyed. So I'm just going to scrape it here with this. Get something there. I mean, obviously I did solder this already, so it's got some solder attached to that side. I was trying to see what was there and how much is left of that. How much was left of that particular trace that's there. So let's just try and see what I'm doing here. Okay, so some trace there exposed. Expose a bit more this side. I'm not happy with that yet. Yeah, it's still corroded right down to that point there. There we go. Yeah, about there somewhere is looking alright. Okay, let's put some solder on this, just on one side. You'll see why it's only one side in a minute. I've got also a piece of wire which I'm going to use to bridge across this thing. So I'm going to form it a little bit first, so it'll go around that corner. Zoom out a little bit, I'm probably going off shot or something. Alright, I'm going to stick that around that corner like that. Okay. I'm going to cut this off because I've got too much. Get there. This is why you keep old component leads and bits like that, because this is what you use them for. Let's solder this end on. Just tap it on, otherwise the whole thing will melt and fall off. Just do it really briefly. And then do the other end. Give it once it's cooled down a bit. Just get a nice flow onto that other trace. We'll probably use some flux on this actually. No, that seems to be alright. That's done. Okay, that's that trace rebuilt. Okay, let's do some more cleaning and then I'll try it again. Alright, I'm going to use some Sigable cleaner for a change, just a little bit. Just to get the worst of this off. And then I'll do the same on the other side as well. Use it sparingly. It's expensive. I've still got to put that connector back on yet. But let's see what flux on my desk. That's got to come off too. Yuck. Flux is disgusting. Alright, let's refit the connector. Now one of those pins which have been, well, those two pins which are eaten away a little bit, these I think are the power supply. So I think that's why they got eaten away, because it had liquid damage whilst it was under power, which is quite a common issue. If something's powered whilst it's getting wet, it will cause electrolysis and actually eat away the copper. So, not surprising. solder stuck to the ground plane then. That pin doesn't do anything anyway. There's only, say, 6 pins that are actually used. These two here, which go to the power plane, and those 2 pins were not in good shape either. The ground plane, that one there, I'm just not sure about this one taking it. There we go. I'm not sure, there might be a break here too. Not sure. Might give that a bit more scrape. There could be a slight break here. So just there could also be a break. Looks like it might be. I might have to patch that one as well. Right, let's try powering this up again. I've cleaned it all up some more. Let's turn on channel 3, which is what I'm currently running to the power supply. So yeah, they're flashed on. That LED still looks very bad. It does not look like a good LED. Anyway, so it's powered up. That's working fine still. So let's plug the display in and see if that works. This is the moment of truth, isn't it? I do have 2 cables here. They've tried 2 cables apparently and neither cable worked, so it doesn't mean that the cables are okay still. But we'll try it anyway. We'll assume that the corrosion on the board was the issue, because I believe it was. So let's go slowly. Plug this in and see what we get. We have a display. It's fixed. So on here you can actually change battery settings, things like that. So it looks like it's actually doing all the right stuff. Okay, there is something happening here. I'm trying to see what's going on. So solar voltage, load, which you turn it on and off somehow. I don't know how to do it. So my unit was different. I had the 50, not the 5. Yeah, okay. So that's load off. Battery saying that's the default setting. Now, can I do any settings on this? Ah, here we go. Settings. Here we go. Yep, you can change settings. Great. So if I do 210 and set. Right, so it should have changed it in here. Let's unplug the display. Plug it back in again. 12.9. Right, so it's, there you go, 210. So yep, two-way communications working. Great. That's fixed then. So what I need to do now is put some solder mask on it. Right, so some UV Cure solder mask. So I've got to push this down, put some on the board, and then spread it out. And then UV Cure it using these things. I mean, I'm going to be pushing my luck here for coverage, but it's going to take a while to do. But anyway, let's push some out of this. Let's get a screwdriver, this will do. And let's pop some out. That's probably plenty. Spudger, just spread it out. Some of these areas are probably better just by soldering over them, but this one I'll do now. Obviously, the thicker it is, the more of an issue it's going to be for trying to cure it. And the hardest thing with this is trying to get a nice even coating so it looks nice, but yeah, I never get a nice even coating, get it looking nice. That just doesn't happen. Anyway, so I'll stick some of this on and get it as well coated as I can, and then hopefully it'll be alright. Well, maybe a brush would be good for this. I don't know. Maybe a brush would be good for this. I haven't tried using a brush for this. Maybe I should use a brush for this. Might be a good way of doing it. Anyway, you get the idea. I'll get it smoothed out, then I'll cure it. Well, it's smoothed out as best I can, so now to try and cure it. Now I've got to try and get underneath here as well, which is why this torch is good. So that's why I'm hitting it with two lights at the same time. This takes a while. The thicker it is, the longer it takes to go off as well, so that can be a bit of a problem too. Can be here for quite some time trying to do this to make sure that it's actually working and actually cure it properly. But there are bits which are quite thick, like where these jumpers are, where I've repaired those. I've got to build up around those to help protect them. So things like that. But anyway, I'll be doing this for a while. Right, the next thing I'll do now is put it back together again. I've kind of setted the board. I've I've seated the board in there. That's sitting there. Now these MOSFETs get pushed down on those sill pads. Got a box of bits here. Well, container full of bits. Let's figure out where all these go. So I've got 3 long screws. So those will be the sill pad hold downs. Alright, so these will be holding down the MOSFETs. That's what these do. Okay, so that's what those are for. That then leaves us these screws. We've got some countersunk ones which are for the casing, and one which is not countersunk, which I think goes over here to hold the board in. It's got 1 screw that holds the board in. 1 screw, that's ridiculous. Anyway, apart from obviously the ones which hold down the MOSFETs, but you've got all these posts on every corner, and yet they haven't put screws in them. They've just got posts to hold it up. Anyway, there's that screw there in. So we've got these pads which go down here with the 2 screws like that to hold the MOSFETs, with these little plastic posts that go through as well to ensure alignment, and I guess make sure they're actually sitting where they're supposed to sit. Something like that. We've got a second one of those, goes there. So alright, interesting construction. Very interesting construction. Not quite sure why it's like this, but there it is. Let's screw this one down. Be a threaded hole there somewhere. Be easier to find if this board was actually lined up by having the screws in the corners. Anyway, that's through there. Not going to tighten it right down yet. But do the same thing on this side. Right, they actually have standoff options. They actually stand off, which is kind of weird. Yeah, it's like puts point loading on. I'm not sure I like that. And that's those. I'm not sure how tight to do these up. Yeah, so they kind of go through the holes and they got a standoff effect. I don't like that. Weird design. They could have had the clearance for the screws. I mean, obviously needed the bars anyway to help pull them down, but I'm not sure I like that design. I just want to make sure the MOSFETs are actually pushed down properly. Let's tighten this a bit more. I don't know how tight to go is the problem because of these plastic posts. I mean, how strong are these? About that much. I think as long as the MOSFETs are pushed down, it should be alright, eh? I mean, it's pushing directly onto the MOSFETs, I suppose. Yeah. So those posts are actually pushing directly onto the MOSFET onto the heatsink. So those actually aren't even holding the board down. Wow. So the only thing that holds the board in is that, and the silicone. Not a fan of that setup. Right, let's put the top cover on. Hopefully all the LEDs and everything line up still. I was tempted to replace the LED, which is just looking a bit weak. I don't know. Not sure. It's not part of the things I have to do, so that lines up. Those LEDs are through. Temperature sensors right there. Those LEDs are through. So it looks like it's down properly. Alright, those lined up. Those line up. Okay, let's put these screws in. They all appear to be the same length. The one thing I need to do is retest, well, test the other cable as well. Retest it as it is, and then test the second cable too, actually. Yeah, trying to get into those terminals is going to be interesting. That's alright, I'll set up a different cable for that. Now, because these are tapered screws into plastic, don't over tighten them if you ever do something like this, because you will split the plastic. Just do it just enough so it's under tension, no more. Don't try and go tight, because the plastic will just split. Don't ask me how I know this. Because I've seen multiple, well, various bits of test gear which I've repaired in the past have had that issue where someone's tightened it down and just split the the handles and stuff like that on the front, where they've just over tightened them. Yeah, anyway. I'll put the rusty screw where the rust was. Then we'll retry it again, one last time. Be sure it still goes before I give it back. Let's rejig the setup. Right, got hooked up the power supply. Got the display plugged in. Let's see what happens when I turn it on. Got it set to 13.8 volts, 0.8 amps. Okay, display came on, 13.5 volts it says. Not very accurate, is it? Anyway, oh no, it says 13.8, there we go. That's fine, that's correct then. Let's actually just check this accuracy, shall we? Channel 2. Let's go down and say 12 point. Let's go down to 12 volts. Yep, that's fine, it says 12. And up to say 15, that should be the range it'll be used in. 15. Okay, yeah, okay, that's fine, that's accurate enough. Alright, put the 30 volts. And it's displaying as a negative right now, because there is no PV input, so it's just running straight. And that's the power that's being lost to run the controller itself. So that's fine, the cable's working. So let's unplug that cable and check the other cable. Let's make sure they both work. Visual inspection, which is what I did in the other one as well. This one looks a bit darker at this end. This one's tarnished. I think this is the one which was in it when it failed. Yes, tarnishing on there. That end looks alright. So yeah, which also means I got to plug it around. I'll try it anyway, in case it still works. It does still work. Cool. So, yeah, that's fine. It does actually still work. Let's just wiggle around. Gone off. That's set in there because I've pulled it out. Just want to play around with it. Come on, it's just going to stand up. There we go. Right. Wiggle it around a little bit. Yep, see, it's dodgy. Yeah, this cable's dodgy. Right. It's okay, she was fully seated. I had the clip pushed in very slightly, so I was getting a bit more freedom of movement. So maybe it is okay. But there is definitely a little bit of green tarnishing on these pins, so I'm going to give those a quick wipe with the fiberglass brush. And I think this cable will be alright. I mean, it's only an Ethernet cable. I mean, you could just use any Ethernet cable, I expect. I don't think it's really a big deal, but hopefully I can show you the difference. So I've actually got this wire brush one. Let's do this because this will get in there. Now it's shiny. That's much better. That left pin's probably going to use a bit more. Yeah, that's better. And I'll do the other end as well. It's probably been a harsh environment. And if it had cable getting wet, it's probably not a good sign, is it? Who knows where the water actually got into? Could have got both ends. Plug that in. Plug that in. Okay, cool. Happy with that. I can give that back. There's a subscribe link over here if you want to subscribe to the channel. There's other videos here, other things I've repaired or other videos I've made. There's also videos in the description which you might find interesting. There's a big list of playlists there. Other things you may be interested in: 3D printing, electronics repairs, electronic reviews, test gear repairs, test gear reviews, all sorts of stuff. Also, there's a Patreon support link over there. You can also buy me a coffee. So if you want to support me on Patreon, that's brilliant. If you want to buy me a coffee, that's also brilliant. There's also do like a one-off thanks thing down the bottom there, or YouTube memberships if you prefer that, whatever. Anyway, thanks for watching. Catch you later.